Hello everyone, and 35 people have joined us right now. And should we wait 2 minutes or
Sure, sure.
so? Starting, let me introduce. I am Mayank Arora, the founder of Sorex Network, this community, and thank you for such a great response on this event. We have crossed around 1,000 to 1,100 registration on this event, and today we have Harsh Rungta with us, and who is a software development engineer at Microsoft, working from past 1.5 years. So he will be teaching you today on arrays and linked list. As our event name suggests, deep dive into arrays and linked list. So Harsh is ready with the masterclass, and I would like to hand over the virtual stage to Harsh now. And
So,
in the end, we will have a Q&A session with which you can ask your queries.
thank you so much, Mank. So, before starting with, I just want to give you some insights about me. I am Harsh. I graduated from NIT Rourkela, and currently I'm a software development engineer at Microsoft. Basically, my work is focused more on the Azure side. So, yeah, it is like challenging work, and I am enjoying it. So, starting with the like masterclass, you can say basic introduction to the basic data structures, uh, arrays and linked list. We won't be covering much of the arrays as arrays is quite straightforward. I'll be going through it, but it will be a quick recap kind of thing. But I'll be going more deep into the linked list section because that is kind of what's important. Just let me know if you can see the screen. Uh, is my screen up?
Yes, I can see your screen, and audience, please comment in the chat box
Yes,
that
it
if you are
is.
able to.
Shall I start?
Yes, you can start
Yeah.
now.
So basically, for the list going, there are different kinds of data structures, of which the most basic one is arrays, and which is followed by the linked list. So let's cover up the arrays first. So what is basically an array? An array, you can tell an array to be a data type which stores information in a contiguous manner. So it like the array is consider array is a collection of like it considers collects similar kind of data elements, and all of the elements needed to be of same data type. The elements of the array they are stored in a consecutive memory locations where each like the first index and the second index is the like two different, not under two different memory locations. They are basically one after the another, which is called a contiguous memory allocations for an array. So main point about the array is it stores a data type of similar data types, and it is a contiguous memory allocation. It needs a contiguous memory allocation. So what are the different operations that we can do on array? The basic operations as in I'm not sure if I am audible to you guys. Just checking once. I guess I am. Yeah, I am right.
Yes, you are audible, and audience can also comment if
Yeah,
Harsh
sure.
is audible clearly.
If there is any hiccup, man, please let me know since I'm not looking
Surely,
at the screen.
surely.
I'll not be able to. Sure. So the different operations on the arrays that we can do and we can perform on arrays are like the basic traversing or accessing an array element, where we will be able to traverse through first element to the last element of the array, where we can obviously insert an element in the array. That is why we store an elements in arrays. We can delete an existing element, and we can even search in an element. So if we go deep into the searching part, so we will be able to get to know different searching algorithms. So we are kind of skipping that for today. And another two operations which are that can be done through arrays are we can merge two different kinds of arrays in two unique ways, and we can also sort an array in ascending descending order. This is again another topic which includes different sorting algorithms. So a quick summary for all those operations which I have listed out in the previous presented slide. We can access an object. Let's say we are starting from first element, and then we'll have to traverse like second element, third element, fourth element, and then we'll be reaching the kth element. Or we can directly for an array we can directly access the kth element. Is one of the benefit, because the memory allocated is contiguous. We know the kth memory lies at which memory, as in if we know the first element of the array is at memory 200, then the kth memory is 200 plus kth memory. So accessing an object in an array is of O one time. Again, and erasing an object, it is a kind of a typical task in an array, because if we want to move this yellow ball from the array, sorry, this yellow ball from the array, we have to take it out of the array. If we take it out, we need to fill this memory which the yellow ball is in with with the successing elements of the array. So we'll need to transfer all the elements a step before. So it will again need a O n time complexity for erasing an object in an array. Again, similarly for insertion of a new object, if we are inserting at the end of the array, it is quite simple. We can just insert an object directly. But if we want to insert an object in the middle or at the first, we have to first make an empty space allocated for this new object, and then we can allocate that object into the space. Again, a replacement of an object of the object we will be doing. We don't need to first erase and then insert. We can just remove the element, and there will be an empty memory, and we can replace the new object that we need to fill in the array in the empty memory. So these are the few operations that can be done on the array. There is we can go deep into it more, like merging and sorting kind of algorithms. For currently we are skipping it since we have a more interesting topic, linked list, for now lined up. So what is a linked list? Basically, a linked list is a data structure, like other data structures. It is a linear data structure basically, uh, which we can change during execution. In a linked list, it consists of a structure which consists of a data type and a pointer, where the pointer to the previous elements points to the memory of the new next node of the linked list. So basically, successive elements are connected by pointers. Also, so in a linear linked list, we have the last data structure, like the last node of the linked list will always points to null, because we there must be an end to a linked list. To a linear linked list, to be very precise, it is easy for us to make a linked list size grow or shrink during execution of the program. But array, we have to decide the size of an array during the compilation time. But for in a linked list, we can do it during the execution of the program. As the previous line suggests, we can make it as long as required. It doesn't waste any memory space. Just for a viewing example, this is a node of the linked list which has the element A. This element A, this node is pointed by a pointer head. Head points to this node A. A is the data of the node, sorry, and it has a pointer which is again pointing to B, which is another node, and B points to C, and C points to null. So this is how basic linked list execution is. So what are basically how to keep a track of the linked list? We must keep a track of the linked list, because if we lose out our head pointer, we will not be able to traverse or do any operations on our linked list. So we must know the pointer which points to the first element of the list, which we can call either start or head, which are the naming conventions, whichever you like to use. Also, the linked list provides flexibility in allowing the items to be rearranged efficiently. We can insert an element in O1 time or ON time. It again depends. We can also delete an element. It won't need us the extra memory usage that extra time usage which we will be using, which will be needing an array, while shifting an elements to the left if you are deleting, and shifting an element to the right if you are inserting an element in between of the array. So for the illustration of how we can insert an element, just suppose we have an linked list which where the head points to A points to B, and B points to C. And now we want to include X into this list. So we have A and we want it to be between A and B. So what we'll do is our current pointer, which is equal to head, points to A. We will make A point towards X and X pointing to B. Earlier, we have just changed two pointers. Like we have A pointing to B, now we have made it A pointing to X, and now the X pointer is pointing to the B node. So this is how we can implement an insertion in the linked list. So the pseudocode for your explanation is we have a structure for the node where we can have any data type, which I have again made it as in to be very like on a broader scenario. I have made it to be an struct of item. This item is basically anything which you can think of or you want to use in, and again the same struct the pointer next, which is pointing towards the next node of the linked list. So for the insertion, we have we will be needing our current element like the head, and the temporary value which we will be inserting. For now for us it is X. So we will be allocating a memory to the temp, and then we'll be this is basically for the memory allocation of the new node which we want to insert. And temp next is current next, and current next is temp. So for now current next is B. Now what we want is temp next should point towards B. So temp next is current next. So basically this is our current. Earlier it was current next was B. Now what we are doing is we are making the temp next value to B and current next to temp. So if this makes sense, current, this is our current, and which is pointing towards temp. This is our temp variable, and temp next is pointing towards B. Temp next is basically current next, which earlier was a B. Uh, Similarly, deletion, we have the same linked list A, B, and C, and we want to delete the B element. So we have current element as A, and we want to delete this temporary element B, and what we ultimately want is this memory to be freed, and current next should be C directly. So what we will be doing is same thing. We'll passing our first node current, and we'll make a temporary element temp. Now the temp is equals to current next, and current next is equals to temp next, and then we are freeing the temporary memory which we are deleted from the list. So it is no longer needed, and to make it like, to avoid memory overflow, we will be freeing this memory so that this memory can be again used by different processes. So to give you another like deep explanation of this code, we have temp node temp. This is our temp. We are assigning temp to current next. Our temp was current next, which is B. We are assigning it to itself, and now we are assigning current next to temp next. So now what we are doing is we are assigning current next to temp, which was B, to temp next. So now our A is directly pointing towards C, and we are freeing this memory of B. So this way we are deleting a memory or deleting a node in the linked list. So to have a quick overview of what we have studied till now for insertion and deletion. So basically insertion, we will be having a record with the new item, or we can create a new record with the new item, or we can pass a new record that we want to insert with the head in our insertion function, which we have seen earlier. The next pointer of the new record is set to the link it to the item which is to follow it in the netlist. We will be pointing our the next of the new record to the item which we want it to follow next, and the next pointer of the previous record should point towards the new item. So in this way, we will be having an insertion in the linked list. Quite similar, we'll be doing the reverse. We will be pointing the previous of the node which we want to delete should point to the next of the node which we want to delete. So basically, we are removing the middle element and we are assigning previous next to the current next in in a simple way. So the main arrays versus linked list topic, which why arrays are suitable for some like some questions, like some problem areas, and why linked lists are more suitable for some problem areas. Both have its own advantages and disadvantages. So going forward, we can use arrays while inserting and deleting an element at the end. As I have all like told you in the first, sorry, sorry for this. Uh, we can always insert or delete an element from an array at the end in O1 time. If you want to like, repeatedly randomly access any element, we just want to know the nth. If you want to like, access kth element, we can do it in O1 time, but in linked list, we will be needing O of n time to access that element. So if we are repeatedly accessing any element, we will be arrays are more suitable for us. And if you want to search in the list for a particular value, again, searching is more easier in array. If we like, go deep into searching of arrays and searching of linked lists, we will be looking that searching in an array is much more easier than searching in a linked list. Again, linked lists are suitable for if you want to insert an element in any place, if you want to delete an element from any place where sequential access is required, the problem areas where we want the access to be sequential, and in situations where the number of elements cannot be predicted beforehand. As I have said, in English we have to define the size of the array during the compilation, but for linguist we can increase the size to any allocatable size which we have in our memory during the program run. So if we don't have a number of elements that we need during the execution beforehand, we will be using linked list for our problems. Again, we have different types of lists. So what we have read till now was basic implementation of linear linked list. So we have different types of lists where we have already have discussed so far is linear singly linked list, or we can simply say linear linked list, where head points towards its next, where head is A points to B points to C, and C points to null. Where in a linear linked list, we can say our last element point will always point towards null and will only have a single pointer. Again, now the next comes is circular linked list. It is kind of, we can say it is much similar to linear linked list. The only thing is, just like as C was pointing towards null, in this linked list, we will be having our last element pointing back to the first element, making it a circular path. Earlier, our C was pointing towards the null, and now we'll be having C pointing towards A itself. So again, C next would be A next would be B next would be C. So if we start with current next, current equals to current next, which will go to B, current equals to current next will go to C, and then current equals to current next will again make it back to A. Next in the line is W linked list. So in W linked list, we have nodes joined. Uh, from this diagram, you can see A can only point towards B. A can't point back towards C, or B can't point back towards A. B can only point towards C. In W linked list, we will be having pointers between both adjacent nodes in both directions. And we can, okay, again, we can't traverse our single linked list backwards. Like we can't traverse, this is a circular linked list going back. We can't traverse from C to B, B to A. We can only traverse A to B and B to C. And C points towards null. But in doubly linked list, we can always traverse A to B, B to C, C to B, B to A. So we have two pointers to maintain in the doubly linked list. One is head and one is tail. Head is the first element of the list and tail is the last element of the list. Main basic operations on a list are we can create a list, we can traverse the list, we can insert any item in the list, we can delete any item from the list. Just like we can add two arrays, we can add two lists into one. But again, adding two arrays and adding two lists is a kind of different operation because for adding two arrays, we'll be creating a new array with data with the memory size of array A plus array B. But if we are concatenating two lists, we are not declaring any new memory. We will be just using the memory of the nodes which the linked list currently has, and we will be adding those two memories in that list. So no more memory usage will be we will be doing in concatenating two lists into one. So these were the most basic things of the linked list. So now we will be looking more deep into what we can do with the list. And I'll try to cover as much as I can. You guys can comment if you have any questions till now. Else I'll going move forward. We will be generally say that list is a abstract data type. So our question is what is an abstract data type and why we try to focus more on abstract data types. Like why abstract? We already have many uh, data types in any languages, like across like integers, strings, but still why we are looking for an abstract data type. So let us consider, isn't it useful if we have an opportunity to define a data type by ourselves and if we can use that? So basically we are leveraging that benefit of the list in for ourselves where we can actually define our own data type and make it like we can have complex problems simpler. So what is abstract data type? It is a data type which is basically defined by the user, and it basically it is more complex than what simple data type look like. A normal integer or a normal character or a normal string depends on the language you are using. So why abstract? Because we have we'll implementing our own data type, we will having our own implementation, we just need to call the function and rest are hidden. We don't need to like go on and repeatedly check it if there is something complex we need to handle. If you want to insert or delete an element or do any operations on the element, we just have to write a function once and we can call it again and again. Our job is done. In our main function, we don't be requiring to repeatedly specify or repeatedly write our insert function. So what is our conceptual idea? Our conceptual basically list like we can insert, we can delete, we can traverse, and everything is hidden. We just need to call a function from the main function, and the rest is handled out into the functions. So for a better understanding, we are taking an example of a linked list. The structure of the node, we have the structure of the node as we have, just say we are trying to get students in a linear linked list. Students in a class in a linear linked list. We have that node stands for we have the roll number, we have the name for the student, we have the age of the student, and our and we have a pointer which will be pointing towards the next node. This is a user-defined data type. We have created the structure student. It's basically defined by ourselves, so it is a user-defined data type node, which is basically an abstract data type. And we are defining an we are type we are using student to be node. Wherever we will be using node, we will be using this structure. And for easy usage, we are just using node instead of type structures student. So how to create a list and how to begin with that. So first, in a linked list, what we need is we'll be needing a head pointer and a node. Basically, our node would be the head pointer, or we can say we can make the first node be pointed by the head. So head is we can define. I'm using the convention of C. So head we are allocating a memory of size of node and giving it to head. Now what head is? Head has role, name, and age. Empty columns for role, name, and age, and a pointer which will be pointing towards the next node if there is any, or it will be pointing towards null if there is only one node in the linked list. So if there are a number of nodes in the initial linked list, we'll be allocating n records one by one. We will be reading in the fields of the records and we'll be modifying the list links of the record so that the chain is formed. So what we'll be doing is we have a just suppose we are calling this complete node as A. A will be again allocating a node B with a new memory. A will be pointing towards B. We will be giving uh, data like roll number, name, and age to the B's memory. And again, the B's next will point towards C. We'll be giving name, age, and roll number for another student C. And if there are only three students, so the C will be point towards that. So this way we can have complete list of all the students. So this is basically the pseudo code. If you guys want, actually you should practice more and you can have this code written by yourself. So that would be more helpful. I'll just give you a basic walkthrough. This is a function create list. We are asking from the user how many elements. Everything is written in C norm. Because because this is the low level language we should start with. So how many elements to enter? It would be a user input. Just supposedly say n. So now we are looping it through n. So if it is the first element of the node, we can say it is the head. Since k is 0, it will be the first element. It would be head. We are allocating a size of node to head, and we are giving it, assigning it to p. Else, if it is not the first element, if k is not 0, it is not the first element. It is p next. Is assigning We are assigning a new memory to the uh, p next, that is a node, and again we are making it p equals to p next. And again we are having a user input to assign roll number, name, and age to the node which we have formed. So we are using the p, so we can directly assign it as p role, p name, p age. And this assigning operator which I'm using is ampersand. It can be different for different languages. So just have it as we can get it like this. And if once we are out, we have p, which is pointing towards the last element of the node. And again, we'll be having p next, which will be pointing towards null, because in this way we have our single linked list done. And then we'll be returning our head pointer, which was pointing towards the first element of the node. So this was all about creating the list. Now coming to traversing the list, what is to be done once the linked list has been constructed and the head points to the first node of the list, we have to follow the pointers. Display the contents of the node as they are traversed. Stop when the next pointers points to null. We'll be just traversing one by one until we reach a node where the next pointer points to null. This is how we can traverse a node. So it has its own uses. Just suppose we want to find a node with us, with the, say x data. We can look for the node if the data is equals to x. We can stop there, else we can traverse to the next node. So just traversing and displaying the complete linked list, whatever data we have. Uh, we have head pointer, and we are making a temporary pointer p to pointing towards head. Until p is null, we'll be traversing. Just we'll be printing the p's data, and we are making p to p next. This count is just to make sure, like, just to display the number numbered of the nodes. Like if it is the first node, we are initializing count to one. If it is the first node, it will just print one, and then the details of the node, and then we are doing count plus plus to make it two for the next round. Right. Just suppose we have A followed by B followed by C. Our P for the first round would be A, then P is P next, which makes it B because A next is B. And again, we are doing P to P next. B is like now our P is B, so B next is C now. After this operation, our P would be C. Since P is not null, we will again enter this loop. We will do P to P next, that C to C next, C next is null, so now our P is null. Now I'll print F, the number of nodes that is already there, and then we'll we can just return, it's a void type, so we don't need to return a pointer. Again, inserting a node in a list, we'll have a pseudo overview. We have a given specific problem to insert a node before a specific node, not at the end or not at the first. If you want to add at the end and at the first, it's easy task. But if you want to add in the between, it's kind of tricky, but it's is easy if you practice much. Specified means some value is given for the node called key. We will be having the value we are looking for, like we are looking for a specific node with a specific value, and we'll be inserting our new data to the place, like, where we'll be searching if this node's value is equal to key, we will be inserting a new node before this node. For now, the example we are using to be student is role, age, and name. We are using the key to be role. So since just going into the implementation aspect a bit, we can't have a roll number to be negative. Or we can say if the roll of the given is negative, we'll be doing it at the end of the list, or at the starting of the list. That is to be decided by ourselves because this is an abstract data type. We are completely owner of this data type, so we can make our own rules. So when a node is added to the beginning, we only need a one next pointer needs to be modified, as in head points towards the first node. Now our head points towards the new node, and the new node pointer will be pointing towards the next node. When a node is added at the end, two next pointers needed to be modified. Like the last pointer, which was pointing towards null, should point towards a new element, and the new elements next should point towards null. When a node is added in the middle, again two pointers needs to be modified. Suppose we are inserting between B and C, B is pointing towards C, so and our new node is X. So now we are assigning two new pointers, B is pointing towards X and X is pointing towards C. Uh, how one node is modified? Has it made to point to the new node? New node points to previously first element. Last node now points to the new node points to null. I have already discussed. This one also, previous node now points to the new node points to the next node. So void insert, basic pseudocode for insert. We are having a node head. We are declaring a temporary value k, and we are declaring three new nodes p, q, and new. We are assigning a size to the new. We are basically making a new node, like new allocating a new memory for the new pointer to be new node to be added in the list. We are getting as input from data from the user, the new node data, and also we are getting an input from the user to be like at which key to be entered, at which place the new node should be entered. So we have a roll number, our P is pointing towards head. We are checking if P roll is equals to number is equals to roll number we are looking for. We will be doing new next is equals to P and head is new. That is at the beginning. If you want to add at the beginning, our P roll is the roll number and new next is P because our new node should point towards the P. Else, if we want to add at the end or in the middle, we'll be looking for like if until P reaches null or P's roll number is not equal and P's roll number is not equals to roll number, we will be doing Q equals to P. Q is our another node, temporary node we have taken for, and P will be pointing towards P next. This queue is just to make sure we have our previous node in handy because we want to change the pointer of the previous node pointing towards the new node and not towards the next node. So this queue is just to make our just to make use of just to make our previous node in handy because once we jump to the next node we can't come back in a linear list. So this is just a temporary node we are keeping in place. So until we reach P's roll number is roll number, we will be doing this while loop. If supposedly we reach the end, that is P is equals to null, then we have the previous node Q, Q next will be new, and new next will be null. Since we are keeping a previous node, since P is null, its previous node would be Q, which we are having in hand. We can make it points toward new and new is pointing towards null. Again, if we find a node where P's roll number is roll number, we again have Q. Q is next will be pointing towards new and new next will be pointing towards P. Deleting a node from the list. So what is to be done if we are deleting a node from the list? Here we require to delete a specified node. Again, we have a field given. Just supposedly say roll number or a name. Name can be same, roll number can't. So we will be choosing roll number. And here also three conditions arise if we are deleting the first node, deleting the last node, and deleting a node in between. It is quite similar. If we are just having two temporary pointers to keep a track. We ask for which roll number to be deleted from the user, specifies the roll number to be deleted. If it is the first element, P is our head, and if P's roll number is roll number which is to be deleted, what we'll be doing is head is pointing towards P next, and we are freeing the memory allocated to P. The head which we got is now we are pointing towards P next, which was the second element, say B, and now we are freeing A, which was B. If it is not the first element, it goes to the else column. We will be traversing until P is null or we get P's roll number is roll number. Similarly, we will be keeping a track of the previous element Q. P is equals to P next. If if this meets, we will be doing P equals to P next. If we reach the first function, first condition, P equals to null, it means the element not found, and we can return that no match found, deletion failed. If we want to delete any other element apart from the first element, we will be doing Q next, which was our previous element, to P next, which was our next element to P, and we are again freeing the memory allocated to P. So the algorithms I have discussed to insert an element, to delete an element, or either traversing a node is not the only is not the only algorithm present. We can deduce our own algorithms. It is quite simple. I have used the most basic simple algorithms which is easy to understand, and once you are like more you can say more used to these algorithms, you can automatically see a different ways to do it. Having two different temporary pointers, say P and Q is the most basic one, which we should start with. Once you start like writing your own, uh, practicing these things on your own, you will be getting a more handy, like more hands on on these things. What we can do uh, on ourselves is we can try adding two lists into one big list, or we can try adding we can try inserting an element in linked list in a sorted order. If we have a sorted order linked list, we can try inserting an element, or we can insert elements at one end and delete elements from other end. If we are uh, if we are focusing on the third part, if we are in, we have a norm, we have a linked list, and we have a norm from our side. If we are inserting an element, we will be inserting it from first, and if we are deleting an element, we are deleting it from the end. So what does this mean? This makes it a queue, which is another data type, but we can say another data structure, which we talk about frequently. Inserting from first and deleting from last is first in, first out queue, which we call FIFO. So again, this is another topic. I guess we don't have much time, so we can stop here. And like, these topics can be taken out later. Uh, we can have 10 minutes for Q&A. What do you say, Mayank? Like, shall we proceed with, or
Sure, sure.
because
I understand that.
yeah, again starting with this will again take me around half an hour to complete it, and I don't want to stop in between. So, oh, as you say,
Surely we can deep dive into, we can do a next part some time next month or around anytime we can do the next part of this session and we can continue
yeah,
this.
yeah, maybe,
And
yeah, sure. That would be better because I don't want to jump onto this, as this will again take some time. Uh, I have quite a few number of slides to the queue, and then the stack implementation, so it goes and goes and goes.
surely we can do, definitely do the part 2 if you are ready. And now we can open the Q&A for the audience.
Yep,
So
I'm just
everyone,
stopping
you, if you have
screen
any
share.
question for Harsh, please throw your questions in the comment box
Please, yeah.
and we will be happy to answer. Aditya says C++ or Java have been big debate these days
So
on this.
it is like C++ or Java. It's your choice. Nothing forced. I just mentioned that C is much lower language. You should start off with. But if you're doing Java, it's well and good. You can continue with that. Uh, I don't want to go deep into this debate. Neither I have any personal choice. It's just I started with C and then with C++, and I have continued with that. So nothing major. Like no hard points on this debate.
Surely. There is a feedback for us also uh, that we should go on some practicality. So, is there any?
So I see a question. We can't do CP in Java. You can definitely do CP in Java. I just said like uh, you can definitely do CP in Java. It's just the lower you start with the most low level language, you will get more deep understanding of how basically the data structures are working, how basically the algorithms are working. So Java in itself is a low level language. So yeah, you can always do CP in Java, and it is a choice by used by me. So for implementing which type of data type does malloc function use? I couldn't get it. What do you mean for implementing which type of data type does malloc? So malloc function is used basically for allocating a data in C and C++. Basically, in C++ we have different ways, but malloc is a memory allocation to any data type which you define. It can be an except data type, it can be a predefined data type. Just we have in my examples, it was all about like the abstract data type which we have created for a student, that was the role, age, and name. Roadmap for DSA, it is quite a broad question, but I'll say what I'll suggest is go on with start with arrays and linked list, and then with a linear linked list, and then you can start going on to stacks and implementing queues with a linked list, and going forward you can have trees, binary trees, and so on. And parallelly, you can go on to having different algorithms such as sorting algorithms, searching algorithms, and then you can deep dive into different algorithms like the DP, dynamic programming, and so on and so on. How many topics should, where was the question? How many topics should be covered in DSA to get placement? So, for a placement point of view, you shouldn't focus on how many topics you should focus on. You are able to cover all the topics. Just give me a moment. I'll be back in a minute.
So if I answer your question, Shruti, see, it totally depends on the company you want to get placed in. It also varies, and it also varies on which college you are, and depending on that college, how many, which companies are coming, and which company you are sitting for in interviews. That totally depends how much DSA you should prepare for that particular company.
So better to be covered for the
And
best.
yes, surely.
Uh, how can someone insert a node in a random location of the linked list? So you must have something for a, you must have a location where you want to insert the node. Random as in you must know where, or as in random you can insert in any place. Or if you have a key you want to insert after that. We have already discussed it in our session. You can go hop to that and watch it once again. Else, if any questions, you can reach me out on LinkedIn. I'll try to answer as much as queries of yours possible. How to solve the problems in lead code using DSA? How this question doesn't stand? How to solve, like, just start from the basic. You will see everything just going on one after the other. So how we implement the DSA can also in Python for tech. So this is what I was talking about. Python is a very high level language. You won't be able to get a complete understanding of how things are basically implemented. And I say most companies don't allow Python in the online test or DSA test the first round. And even in interviews, they won't prefer Python as their uh, coding language. So better be it in C, C++, or Java. Is game development not a good career in India? It definitely is. You can always opt for a career which you find good for yourself. Best book for DSA in Java, can you suggest me? I, I'm not, I have never like worked in Java or kind of followed Java, but what I followed was a book by Bala Subramanian. It was in C++ though. How can we delete any specific node from the linked list? Just hop onto the part of the video. Your college name, I'm from NIT Rourkela. Fresher, I should start with C++, then DSA. Uh, Learning a language is not a big deal. Learning data structures and algorithms is a big deal. So start with any language and then start with DSA as soon as possible. Best book for DSA, game development not a good career. Which computer language companies preferred most? Either C, C++, or Java. You can hop onto Python once you are well versed in these two. Can we say array is also a pointer? Uh, we can have a pointer implementation to an array, but beyond pointer makes things more tedious. So if we can use arrays without a pointer, then why to go deep into the pointer section of this? It won't make things any better if you are using a pointer to the array. Definitely, array is also a pointer, but it is a contiguous memory allocation. So can you explain some question with a practical way? I can definitely, but I had some personal constraints in presenting, so this made me a bit uh, how or I'll try to maybe on the next session. How can I run codes that my i3 is not able to perform? You can use online editor, and I'm not sure if you're talking about MLAI things because normal DSA codes are. i3, if you're talking about core i3, Intel i3 thing, it can run any normal DSA codes. Or you can use any online editors. Certificate, you skipped my question, sir. Which question do I think this is your question? How can I run codes? Try to use online editors. There are many online editors you can use. How to get praise in Microsoft? Be well prepared. Appear in the interviews. Do your best. And if you need any help, I am there. Yes, ML. So this I'm not a ML expert, though I have a few understandings. So you can implement ML. You can buy in a student discount, not buy. Basically, you can have Google Colab. We have Google Colab, so where we can run our ML codes. I have used it in college, so not a big fan or big. Uh, I don't have much understanding, but yeah, Google Colab works. It seems that only focusing on the presentation may not be the best use of time. Yeah, true. You should focus more on practicing. This was just to give you a kickstart. As currently hiring freshers, uh, but again started hiring as far as I know, and if I'm not wrong. Thank you so much. This was it. I suppose no more comments. If I have skipped any by mistake or by chance, you can just please
No
comment.
problem. I have shared your LinkedIn profile in the comments, and let me
Uh,
share it once again if anyone wants.
does internships you did in college have impact in getting selected by Microsoft? Bro, I was an intern in Microsoft, and I am placed in Microsoft. So yeah, kind of internships definitely do help.
So,
Big.
guys, I have shared.
Yeah, please go on.
Please continue. Please, sorry to interrupt.
I was saying a big shout out to Mayank and Sorex community for giving you an opportunity to giving me and you guys an opportunity to connect basically. So yeah, thank you, Mayank.
Okay, thanks a lot for your time. And I, guys, I have shared Harsh's LinkedIn profile in the comment box. For further queries, you can DM
Yeah,
him on LinkedIn, or
Mayank, you're
and
not
he
audible.
will be happy to answer.
Yeah.
Oh, am I audible now?
Yeah, you are. You are.
So I was saying that I have shared your LinkedIn profile in the
Yeah,
comments. So for further queries, students can connect to you on
yeah,
LinkedIn. And
yeah. To connect with
thanks
me,
for
and
your
I'll try
time.
to answer as fast as possible. I am an active member on LinkedIn, so yeah. Thank you, Aditya. Thank you, Sonia. Thank you, Pawan.
So thank you everyone for joining, and special thanks to Harsh for giving his time to us. And I hope if you liked and give your if you want the second part, you can comment also. We will surely happy to collaborate with Harsh again.
Sure.
And
I'll thank you. Shall
certificates you will be in your inbox by end of the day or by tomorrow, I think.
thank you, everyone. So shall we close it then?
Yes, surely.
Yeah, sure. Thank you. Bye bye.